Hi folks, Mr. Long here with a screencast on inverse trig. And so this is interesting. I actually quite like inverse trig. It's a totally different topic, and it's one that's not normally addressed in high school in Ontario. It is in the rest of the provinces. I guess Quebec and Ontario are the only two provinces that don't address it. And it's nice to go back over and look at right angle triangles again too. So first thing I want to talk about is to develop the ideas around what inverse trig functions are. And you've used inverse trig many times, like you've done like this, sine to the negative 1 of, oh, I don't know, root 3 over 2. And you've known that that's 60 degrees, right? So you've done it, you've used it many times. If you've taken physics, you've done it many, 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 many times. So let's start going through this. So the first thing we're going to deal with is let's look at the idea of isolating for x with inverse operations. So say we've got an equation right here. Here's our equation, y equals the cube root of x, and say we want to get x by itself. So what operations do we apply to it? Well, if I want to get x by itself and it's currently cube root, what's the inverse of that? Cubing. So I would cube both sides. So I'm going to cube there and I'm going to cube there. And what would we get? Well, cube root of x cubed is just x, and then that's y cubed. So that's isolating for x. So notice we do the same thing to both sides. Now here's what you often don't think of when you do this with sine and cosine and things. So say we start out with if sine inverse of x equals y and we want to get x by itself, what's the opposite of sine inverse? Well, sine inverse is what you do to a ratio to get an angle. Sine is what you do to an angle to get a ratio. So let's take a look at this. So the opposite of sine inverse is sine. So what I would actually have to do is, whoops, here, sine of both sides. So I would do the sine of all of that, but I also have to do sine on the other side. Now, what's the sine of sine inverse of x? Well, it's no different than cube root cubed. It's an undoing operation. So the only thing you have on the left side now is x. And x would equal the sine of y. Okay, that's isolating for x. So let's take a look now at, that's just the general idea of doing inverse operations. Now let's start to look at Sohcahtoa. See if you remember some Sohcahtoa stuff. So here's an example. Let's go through number 1. So what we've got here is an angle y in this triangle. And I always just draw an arrow across and write OP to the opposite side. And then I immediately label, in this case, the hypotenuse because it's given. So the question is, if x equals 0.5, then y equals blank degrees. So where x is going to equal 0.5. And we need to figure out what the angle y is. So what do we know? Okay, so I'm starting with angle y. And what ratio links h and OP? Well, it's sine, Sohcahtoa. Sine is opposite divided by hypotenuse. So in this case, I'm going to have the sine of angle y is an angle, equals opposite 0.5 over hypotenuse 1. 0.5 over 1. And that's your ratio. So I'm going to write that again, repeat that. So sine of y equals 0.5. And then what we're going to do here is apply our inverse operations. So I want to get y by itself in this case. So how do I do that? What's the inverse of sine? It's sine inverse. But I can't do sine inverse on one side without doing it on the other side. Okay? So when I do that, what happens? So what's the sine inverse of sine? Just y. So y, remember y is our angle, equals, this is the right side, I just repeat that, sine inverse of 0.5. And that equals 30 degrees. Okay, folks, that's your answer, 30 degrees. So look at that process right there. Okay, look at that process. And you're going to repeat that. So hopefully you've printed out the handouts. And you're going to repeat that for part 2 or number 2 and number 3. Number 2, you're going to use cos, and number 3, you're going to use tan. Okay, so this is going all the way back to grade 9, or grade 10 rather, but you need to go through that. And so right now what I'm going to do, you should do, is pause it and then go through and do that, and then check your answers. So folks, what I'd like you to do now, hopefully you went through that, and now just take a look at your at the answers here. So you should have gotten 60 degrees for number 2 and 45 degrees for number 3. And again, the thing I want you to emphasize here is this notion that tan inverse of tan is just tan inverse of tan y is just y. Okay, so that's all it is. It's the inverse. Tan inverse is the opposite or inverse of tan. Tan, we take the tan ratio of angles, or tan ratio, sorry, of, yeah, tan ratio of angles and tan inverse of ratios. Okay, that's important. Tangent is taken of angles, tan inverse is taken of ratios. That's also important. Okay, and we're going to stop that there. That was just a quick overview or review of right-angled trig.